Grinding is a machining and manufacturing process used for material removal and surface finishing. The cutting tool in this process is known as the grinding wheel and is capable of removing material with precision unmatched by both milling and turning. This can be used for both tolerancing and surface finishing, both of which are very important finishing tasks in machining. Grinding can also be used for the sharpening of tools such as the cutting tool of a lathe or the edge of a knife. Some common applications of grinding include the finishing of curved, flat, and circular surfaces, the finishing of inner diameters such as the cylinder wall of an engine block, sharpening cutting tools, removing burrs from manufactured parts, and polishing and or buffing of specific parts. This process generally works by having the grinding wheel composed of abrasive particles that are bonded into the shape of a wheel. When the wheel comes into contact with the workpiece, it acts as a cutting edge that removes material in the form of tiny chips. As it removes workpiece material, worn abrasive material from the wheel becomes dislodged. This allows unworn abrasive particles to perform cutting, allowing the wheel to efficiently remove material throughout its hours of operation.
Some of the major parameters that add to the quality of machining process are grinding wheel material, wheel speed, and lubrication. Successful grinding requires the abrasive wheel material to be harder than the workpiece. It must be heat resistant, shock resistant, and also capable of fracturing to allow new layers of abrasive to emerge. The grinding wheel can be operated at different speeds. Higher speeds are usually desired for better surface finish. Lower speeds decrease the grinding temperature, however, this can also be remedied with sufficient lubrication. The rotating speed should not exceed the safety limit since it would cause the wheel to crack and can lead to breakage. Lubrication is an important aspect that is necessary in grinding. Large amount of heat is generated due to friction forces between the abrasive wheel and workpiece. This can compromise the part or even the wheel, and so proper lubrication must be utilized. Common examples of lubricant include coolant and different grades of oil. When performing grinding, the efficiency of the grinding wheel must be maintained. To do this, the grinding wheel must undergo balancing, truing, and dressing every so often. Balancing removes vibration at high rotational speeds, while dressing breaks off dull abrasive material from the wheel. After dressing, truing ensures that the wheel remains cylindrical and round.
Some of the major types of grinding are surface grinding, cylindrical grinding, centerless grinding, and creep feed grinding. Surface grinding is a process in which the workpiece moves relative to the grinding wheel as it removes a small layer of material. This creates a flat, smooth surface. Due to the high amounts of precision and accuracy involved in this process, it is often used when tiny tolerances are needed in the workpiece. Cylindrical grinding is a type of grinding that requires the workpiece to have a central axis of rotation. The workpiece and grinding wheel must constantly rotate relatively to each other. While the workpiece remains stationary, the grinding wheel is fed towards and away from the workpiece. The grinding can work on a variety of shapes, including cylinders, ellipses, cams, or crankshafts. In centerless grinding, the workpiece is not mechanically constrained. Instead, it is held in place on top of an angled work blade and in between a high-speed grinding wheel and slower rotating regulating wheel. The combination of these three key parts allows for any irregularities on the cylindrical workpiece to be evened out. When set up correctly, this process can rapidly create large amounts of incredibly precise, round surfaces. A more exotic type of grinding is creep feed grinding. It is used to remove much larger amounts of material than conventional grinding, by increasing the depth of cut and decreasing the feed rate proportionally. This process is used to better preserve the surface of the workpiece or create curved surfaces for plane wings or turbine blades. There are many more specific types of grinding processes, and the ones previously mentioned are just a portion of what is actually used in real-world manufacturing. Grinding is a highly accurate manufacturing process used to remove material and create smooth finishes. This is done by a hard, rotating abrasive grinding wheel making contact with the workpiece. Important parameters that add to the quality of the process include wheel speed, material, and lubrication. Some significant types of grinding are surface grinding, cylindrical grinding, centerless grinding, and creep feed grinding. Overall, this manufacturing process can be used to create curved surfaces, polished parts, or finished products that require tiny tolerances.